Well, good evening, class. This is Algebra 2, Lesson 1.2, Polynomials. So hopefully you've clicked on the correct lesson and are watching the correct lesson here. A flipped classroom, first time doing it, and hope that you'll enjoy the lessons this year, as we'll occasionally flip the classroom, allow you to watch the lesson at home, and then come into school and work on the problems when you get to school tomorrow. Just a reminder, remember, take notes. Take notes, and that will help you as you look back at your notes to study for quizzes and tests, and will also help you as you try to work on the homework tomorrow. So Algebra 2, Lesson 1.2, Polynomials. And as it is in the beginning of this course, uh, a lot of review. So I'm going to go kind of quickly, and hopefully I can answer any questions that you might have tomorrow in class. So by way of introduction, question would be, what is a polynomial? So it's, for a lot of you, it's been over a year since you had Algebra 1, and you remember what a polynomial is. Well, it's simply this. It's an algebraic expression of one or more terms. An algebraic expression of one or more terms. So what would one look like? Generally something like this. 3x squared minus 2x plus 7. That's a common polynomial, and there are a lot of them. So just a refresher, what is a term? A term is a mathematical expression, a group of numbers and or variables that are separated by addition, or the opposite of addition, subtraction. So in this example here, it's a polynomial with three terms. The 3x squared is the first term, the minus 2x or negative 2x is the second term, and 7 is the third term. All right, if you remember, we have some specific names for some of the polynomials. Specific names. And so the first one is for a one-term polynomial. A one-term polynomial. And hopefully, I'm sure you all remember 1. If you think of a prefix for 1, hopefully you're thinking mono, and so it's a monomial. Then, of course, we have a two-term polynomial. And again, you're trying to think of prefixes for 2. Maybe you're thinking die, but it's not die. It's like the bicycle, 2 wheels, and so you're thinking bi, and so it's binomial. And then the third specific name is for a three-term polynomial. And think about when you were, I don't know, 3 years old, 4 years old, you had that bike with 3 wheels, and it was, of course, a tricycle. So we have a trinomial. All right, so polynomial with one term, monomial, 2 terms, binomial, and 3 terms is a polynomial. And here, let me go back and fill in a couple examples here. What would be a one-term polynomial? How about something like this? Negative 7x squared y divided by z. Believe it or not, there are a lot of variables involved, 3 different variables, and a coefficient, the negative 7, but that's just one term, because none of the variables and or coefficient are separated by addition or subtraction. And so that's one term. Right? That would be a monomial. A common binomial would be something like this. 7x minus 3. That would be a common binomial. So the 7x is the first term and the negative 3 is the second term. Right? Common binomial there. And then here would be an example of a trinomial. How about something like 5x squared minus 2xy plus y squared? So in this case, the 5x squared is the first term, the negative 2xy is the second term, and the positive 1y squared is the third term. Right, so specific name. So what do you have if you have a polynomial with 4 terms? Well, we stop using the prefixes at that point. We just call it a polynomial. 5 terms, we don't say a pentanomial, we just say polynomial. All right. So 1 term mono, 2 bi, 3 tri, and everything else we'll just call a polynomial. And of course, all of these are polynomials as well. All right, so let's get into some specifics here. Number 1, the degree of a polynomial. The degree of a polynomial. How do you figure out the degree of a polynomial? And I'll remind you of this later when we get polynomial equations, but this is an important aspect because remember, the degree of the polynomial equation is the number of real and or imaginary number solutions for the equation. And so the degree of the polynomial. All right, so I don't know if you remember all the way back to Algebra 1, but the degree of a polynomial is the, and I'm going to use red here, degree, back to blue for a couple words, of the, and I'm going to finish in red, highest degreed term. Highest degreed term. What is the degree of a polynomial? The degree of the highest degree term. So let me show you a couple of examples here. So let's suppose we had, here's a very common trinomial. 5x squared, 5x squared, let me clean that up here. 5x squared minus 3xy plus 4. Okay, so now I have to begin to think, how do we figure out the degree of a term? Because here we have a trinomial, we have 3 terms. And I have to figure out which term is the highest degree, because the degree of the polynomial is going to be the degree of the highest degree term. All right, so we're not going to write this definition. It's something you should have learned in Algebra 1. And so we said this. We said the degree of a term, right? The degree of a term is the sum of the exponents of the variables of that term. The sum of the exponents of the variables of that term. So if you figure out the degree of the first term, it's a second degree. Now, here's the second term, and of course, both the x and the y have an understood one exponent. Add those up, and we got a second degree term there as well. Well, the 4 has no variables, and therefore no exponents of those variables, and it's a 0 degree. So what is the degree of the whole polynomial? Well, what's the highest? In either case, it's second, and this is a second degree polynomial. A second degree polynomial. And that's the way these go. So this is specifically a trinomial of the second degree. A second degree trinomial. Let's do another example. How about something like this? 7n cubed minus 4, we'll go x, y, plus 5 to the 4th x squared minus 3 wx, y, z. All right, interesting. So again, that's a 7n cubed minus 4xy plus 5 to the 4th x squared minus 3 wxyz. All right, first off, it's just a polynomial because it has 4 terms. So you want to figure out what's the degree of each term, and then pick the largest one, and that will be the degree of the polynomial. So go ahead and take a moment and see if you can figure out what is the degree of this polynomial. By the way, feel free to pause the video at any time you need to. Feel free to rewind the video at any time you need to. So you might want to pause right now and give yourself time to work, and then unpause it when you're ready to go. Okay, so the first term is third degree, right, because of n cubed. The second term is second degree because 1 plus 1 is 2. What about that third term? All right, be careful here. The third term is second degree. It is not sixth degree. We do not consider exponents of numbers, only the exponents of the variables. And then what is the fourth term here? 1, 2, 3, 4. Oh, this is a fourth degree. So what is the degree of the polynomial? This is a fourth degree polynomial. All right. Figuring out the degree of the polynomial. I want you to write in red underneath, and again, I'll bring this up constantly throughout the course. Let's see, for polynomial equations, for polynomial equations, there are as many real and or imaginary solutions. There are as many real and or imaginary solutions. There are as many real and or imaginary solutions as the degree. There are as many real and or imaginary solutions as the degree. So for example, let's suppose you had something like this. Y equals 5x to the fourth minus 7x squared plus 2x minus 3. 5x to the fourth minus 7x squared plus 2x minus 3. All right, this is a fourth degree, and that would imply that there are up to four solutions. Now, sometimes those solutions are the same number twice. 3 times can be even 4 times. And again, sometimes they're real numbers, sometimes they're imaginary numbers. We'll get into this a little bit later on, but just a quick refresher. What is an imaginary number? It's the root, the even root, square root, fourth root, sixth root of what? It is the even root of a negative radicand. Even root of a negative. All right, if you don't remember that, don't worry. We're going to get into more detail a little bit later on down the road, but that is what we're talking about when we talk about imaginary numbers. Okay, so degree of a polynomial. Everyone should know how to do that. Number two, like terms. Like terms. Now, I'm not going to take the time to write out the definition. We did this a lot in Algebra 1. If you need to write it out, go ahead. Here's the definition of like terms. Like terms are terms with the same variables, and those variables have the same exponents. Terms with the same variables, and those variables have the same exponents. Right? Definition of like terms. So let me show you some like terms. Something like 7x squared plus 5x squared. All right, so notice they have the same variables, but also notice the variables are to the exact same exponent. And you got to have both. And if you remember, what I taught you in Algebra 1, hey, there are 7 of the x squareds and 5 more of the x squareds. So, or you can say it like this, 7 of them and 5 more of them, they're the same thing. Remember, the coefficient number out in front tells you how many you have of them. So 7 of them and 5 more of them would be 12 of them. And in a minute, we'll get into adding of like terms. Right. Be careful with something like this. 5y squared minus 3y. These are not like terms. So these are not like terms. Because even though they have the same variables, a y in both cases, the variables are not to the same exponent. So you could not add those. So that brings us then here to C. And I'll write it in red. Only like terms can be added. only like terms can be added. If you want to include or subtract it, feel free, but remember, subtraction is just the opposite of addition, just adding of negative numbers. So only like terms can be added. And how do you add like terms? You simply add the coefficients. Add the coefficients. Again, what are the coefficients? The numbers that are the multipliers of the variable. Add the coefficients. That's all you have to do. Add the coefficients. Real simplistic example. Let's suppose we had something like this. 7x cubed minus 9x cubed. Alright, we do have like terms. Same variable. The variable is the same exponents. What's the coefficient of the first term? Positive 7. What's the coefficient of the second term? Negative 9. 7 positives of them and 9 negatives of them leaves you what? 2 negatives of them, right? And so that's a negative 2x cubed. Only like terms can be added. And then D, if, and I'm going to put this in quotes, subtracting polynomials. If some subtracting polynomials. That implies, for those of you that are new, that's the imply symbol that I use very, very often. So just simply it reads that implies. So if subtracting polynomials, that implies, don't forget to, and I'm going to leave a blank here, blank the negative. Don't forget to blank the negative. Alright, so maybe you don't remember what goes in the blank. Let me show you by way of example. Let's suppose we had something like this. 3x minus 7, that's a binomial, and then minus, and here comes our second polynomial, 5x minus 3. So the 3x minus 7 can have a parentheses around it, doesn't really need to have one. So, but you're subtracting the 5x minus 3 from the 3x minus 7. So if subtracting polynomials, that implies don't forget to blank the negative. So what word goes in that blank? And hopefully use the word distribute. Don't forget to distribute the negative. So remember, this negative gets distributed to both. Now we can add up our like terms. So you end up with a positive 3x and a negative 5x. A positive 3 of them and a negative 5 of them leaves you a negative 2 of them. And we'll do the back terms, or the numbers. This is a negative 7, but be careful here. When you distribute the negative, you get negative and negatives a positive. 7 negatives and 3 positives leaves you 4 positives. And our solution is negative 2x plus 4. Adding like terms. We'll do just a few more examples, and that's going to be it for this lesson today. So E, examples. Number 1. So just a couple more examples and we're done today. So how about something like this? 5x squared y minus 3n plus 7n plus 4y x squared. Alright, what I want you to do is add like terms. Now again, if you'd like to do it on your own, go ahead and pause the video, do it, and then turn it back on. Otherwise, I'm going to give the solution right now. Okay, so I'm looking for like terms. Well, hopefully you look and see the 5x squared y and the positive 4yx squared are like terms. You know, if you remember back, what property tells you that the order of things don't matter as long as they're being multiplied or added? and that would be the commutative property, right? And so 5x squared y is the same as an x squared y is the same as a yx squared. They are like terms. Do they have the same variables? The front one has an x and y, the back one has an x and y. Are the variables the same x one? In the front one, the x is squared. In the back one, the x is squared. In the front one, the y is to the first. In the back one, the y is to the first. They are like terms, so we can add them. And by the way, notice I always box in the sign in front of the coefficient because it really goes with the coefficient. All right, 5 of them and 4 more of them is 9 of them. Now, how should you write your answer? X squared y or yx squared? Well, formatting purposes, you usually go in alphabetical order, so we're going to choose the x squared y. All right, so we have 9x squared y. Now we'll look and see, are there other like terms? There are. There won't always be, but there are. We have 3 negative n's and 7 positive n's for a positive 4n, and we added like terms. Okay, just one more example, we're done for today. How about something like this? How about 8x cubed minus the quantity, so minus parentheses, 5x cubed minus 7x. Alright, so in this case we have a monomial, 8x cubed, and then minus a binomial, 5x cubed minus 7x. Alright, so again, try to work that one. Pause if you don't want to hear the solution here in the next couple seconds. Alright, and here we go. So again, you see that negative and you know, hey, I've got to distribute this negative. It's going to give me a negative 5x cubed and a positive 7x. Look, if you can't do it in your head, then just rewrite the problem. Now, usually Algebra 1 we're going to rewrite. This is Algebra 2 and we got to do some time saving. But if you can't do it in your head, rewrite the problem, right? A negative times a positive 5 is a negative 5. A negative times a negative 7 is a positive 7. Okay, like terms. I have 8 of the x cubes and a negative 5 of the x cubes for a grand total of positive 3 of the x cubes. And I have nothing to add the 7x to, so it just goes tacked on to the end. And that is the solution, 3x cubed plus 7x. All right, guys, flip the classroom. About 22, maybe 25-minute lesson. And so hopefully you took good notes. Come on in the class tomorrow and we'll work some problems over these concepts. All right, have a great night. See you tomorrow.